back. Now we're going to do some equations. So we did one beforehand. Now we're going to look at ones where we mix it up a little bit. Okay, so it's not quite as simple. We're going to add some things in where direction is important, but we can do this. Here we go. First question. A ball is thrown upwards at an unknown initial velocity, so we don't know VI. It takes 3,2 seconds to reach its highest point, and then they ask us to ignore the effects of air resistance, which is great. They'll do that with all of them, and they want VI. Right. Let's draw a diagram. Here we have my object, the ball. It throws up, and it gets to here. What they tell me is I don't know initial velocity. They do tell me, though, that it takes 3,2 seconds to get to the top. We now need to sort out what is the implied pieces of information. The first one is this. My final velocity is 0. It's reached the top of its motion, and it's about to come back down. We know acceleration due to gravity is 9,8. But that's down. Ooh, that should be a 2. But that's down. We need to make a decision as to what is our positive direction. I always take initial direction of motion as positive. If I take up as positive, that means this acceleration is negative. We like a question like this because hopefully you can already see if I go VF is 0, VI is what I'm looking for, A is minus 9,8, and delta T is 3,2 seconds. This is nice. It's the first equation. It's the easiest one to use. So we know that VF equals VI plus A delta T. VF is 0. We want VI. That's minus 9,8 times 3,2. We definitely need to put our calculators in this one. So we've got 9,8 times 3,2, and that gives us 31,36. Oopsie, I didn't mean to do that. Let's go back. No, that's 0. 31, and that's a minus. It's always important to write it down properly. We want VI on its own, so when we swap it all around, but it's a vector. We got a positive answer, which was expected because I took down as negative, I took up as positive, it was thrown up, so this is up. Not so bad. Let's see what the next question has for us. Now we have things that are slightly different. Now they say a ball is thrown upward from the top of a building, of a 30-meter high building. The ball takes 2,4 seconds to reach its highest point. You must read these times carefully because a lot of you are going to read this and go, that's the time it took to get to the ground. It's not. So here's the building. It gets thrown up and it takes 2.4 seconds to get to here. Then it goes down. So I don't actually know the total time. Then they ask you, calculate the velocity with which the ball left the thrower's hand. In other words, initial velocity, and then calculate total time. We're going to show you a trick to that. Here we go. First thing that we've got, here's my building, which is 30 meters. My ball gets thrown up. It takes 2.4 seconds to get to this point before it comes down. This first part of the question is exactly like the question we've just done. I want initial velocity. I know the final velocity, which is going to be 0 because it's at the top of its motion. We know acceleration every single time, 9,8 meters per second squared down, and I know time. Nice and simple. What do we need to make a decision about? Sign convention. I'm going to take up as positive. I know my final velocity is 0. My initial velocity is what I'm looking for. My acceleration is now going to be minus 9,8. And my time, 2,4 seconds. Same equation we just used. So VF equals VI plus A delta T. VF is 0. We want VI. This is minus 9,8 times 2,4. Absolutely need a calculator. Let's get rid of that. 9.8 times 2.4. And it's 23,52. Oh, only one. There we go. Let's just not put an equal sign. I get very excited. Now I can't remember the answer. 23,52. Therefore, this is going to be 23,52 meters per second up. Please don't expect that every equation of motion that you're going to get in this is going to be some sort of trick, because it's really not. Okay, look at the mark allocation. This is only worth 3 marks, means 1 equation. Let's get to the next one. Now they want the time it takes for the ball to reach the ground. So we remember we've got 30 meters here. We've just worked out that the ball's going up at 23,52, if I'm remembering correctly. There we go. And we know that it takes 2,4 seconds to get here. And now they want the total time. This is where vectors become very special because of our sign convention. So we can't change the sign convention. This question would only be worth 3 marks. So I'm going to show you one way to do it, and then I'm going to show you another. We can do this in one step, in one equation. And it's about your convention. So up was positive, and they want to know what's the time when it gets here on the ground. I don't know what that final velocity is. I also don't know what this full distance is. But what do I know? So if we look at this, we've got VF, we don't know it. VI, 23,52 meters per second, and it's up. A is minus 9,8. Delta T is what I'm looking for. Now we've got to discuss what delta Y is. We said up is positive. Anything that goes below my starting point is negative. Over here, this is my starting point. That's my 0 line. Anything that goes above it, so any displacement above that is positive. Anything below it is negative. This is minus 30. That's the big thing here. That's very much the big thing here. So here we've got to pay attention. We now look at this and we go, it's not the nicest equation, but we can use it. Because now we can use delta y equals VI delta t plus a half A delta t squared. We have minus 30. We have 23,52 times delta t plus a half times minus 9,8 times delta t squared. And right about now, the wheels fall off. Now we look at this and we go, that's impossible. No, it's not. This is remembering some stuff from maths. You're now going to have to use the quadratic function equation, okay? So we've got minus 30. This is 23,52 times delta t minus 4,9 times delta t squared. If I manipulate this, I'm going to get 4,9 delta t squared minus 23,52 times delta t minus 30 equals naught. Now it looks like a quadratic. Now it looks like an equation you've used before. If you get to this point in an exam and you look at that and you go, yeah, I can't remember how to solve those, because you just can't. You know what? Leave it. It's 1 mark for the answer, okay? It's 1 mark for the answer. You've got the science. At this point, I'm going to remind you, I just need to rub some stuff out so that I've got space. So if we go here, I'm going to remind you what the quadratic function looks like, because we know we don't always remember it. And unfortunately, it's not going to be given to you on your information sheet. So you remember from maths that the quadratic function is this, that x would be equal to minus b plus or minus square root of, this is why you've got to remember it. I do remember it, b minus 4ac over 2a, okay? So when we look at this equation, 4,9 is a, minus 23,52 is b, and minus 30 is c, and delta x is x is delta t. So if we substitute it in, we're going to have minus 23,52, because it's negative, plus or minus the square root of minus 23,52 squared minus 4 times 4,9 times minus 30. Okay, and I've gone over, this is very badly laid out, with 2 times 4,9. The first thing you need to take note of is if that underneath your square root bracket, underneath that, if that ends up being a negative value, you've made a mistake, because you know you can't take the negative of a square root, okay, square root of a negative number. That's the first thing. From here, now it's all a maths thing. I'm going to solve what's in the bracket first, because I want to get rid of that square root, not the bracket, the square root. So I've got, let's do it this way, minus 23.52, oh wait, I've got it twice, let's not do that, minus 23.5, whoopsie. I can use the calculator, squared, minus 4 times 4.9 times minus 30. And I've got 1,141. It's a positive number, and I'm actually going to take the square root of this straight away because of space. I'm going to take the square root of that answer, and I get 33,78. So this has become 23,52 plus or minus 33,78 divided, and 2 times 4,9 is 9,8. Straight away, I'm hoping you recognize that I'm not going to go 23,52 minus the 33,78, because that's going to give me a negative answer. Watch, okay, just in case you don't believe me. So if I go 23.52 minus 33.78, and then I divide by 9.8, I get an answer that is minus 1,04. So the first answer we could get is minus 1,04 seconds. Hopefully you'll recognize we can't have a negative time. That's silly. It's definitely not going to be that answer. Let's see what happens when we add them together. So we could do, so we've got 23.52 plus 33.78 divided by 9,8, and we get 5,84. Now that time makes sense to me because it took 2,4 seconds to get to the top of the motion, and now it's going to take more time to get to the bottom. So even this minus 1,04 doesn't make sense because then it took less time to get all the way to the bottom than it did just to get to the top, okay? And I know that was quite difficult. You could do it, and I don't like doing it this way. You can work out the time it takes to get to there and there. That's 2,4 and 2,4, and then you can work out that little distance and add them all together. I don't like doing it that way around because there's lots of little places we can make mistakes, and you may need to just think about this one for a little bit, okay? That one was hard, but you've done a lot today. We've done the equations, you've done some definitions, make sure you learn them, and now we're going to need to go and take a break. So we're going to end there for today, and I will see you next time.